In our last video, we talked about using the matrix class, and now I'd like to give a more practical example of what you can do with matrices, matri- whatever they're called. And I am a computer nerd, not a math nerd. Remember that. And let's just dive in. And we'll use the geometry class in this one as well. So this is completely unrehearsed. So bear with me as we muddle through this. All right. So we've created our reference. We created our main sub and all that stuff. We created a dog waffle from the dog waffle class and all that stuff. So we've already created a matrix object. So let's create also a geometry object and give it load object and a fully qualified path. Remember, this is going to be Howler that's seeing this, so it's going to be seeing it from Howler's viewpoint or where the folder that Howler is in. So you want to give it a fully qualified path instead of the path whatever you happen to be in. That is important. And let's do something simple. Debug.print g. Face count? No, let's see. I want vertices count, vertices. And print that. And lo and behold, it works. It prints the number of vertices in our object. So let's actually try to do something with this now. Let's draw this to the screen. So dimd as new VB drawing. And we'll do a begin draw and an end draw. And draw. 3D is another thing. We'll come back to that later someday. Let's see. We're going to draw this. This is going to get involved. Okay, remember our geometry class requires a 3-point faces with 3 points instead of 4 points or more. It's really designed to be future forward is designed to be used with possibly we might get some ray tracing or something in there someday, and we want to keep it simple. So we decided up front that it would just be 4 3-point objects or 3-point faces. So bear that in mind when creating content. Anyways, so let's do this. Let's get the count. G dot, what was it? I was using vertex count. And go for n equals 0 to c. I think it should be c minus 1. Anyways, and next. And here's where it gets a little more involved. Let's see. We want to draw. What do we want to draw? We want to draw the faces. No, we want to draw the vertices. So, maybe we'll just draw a point for each vertex for now. Let's put a sphere where each vertex is. So that'll be simple. Let's see. So g dot. We want to get a copy of these vertices. So let's. Am I using v yet? Let's as a variant. Let's do a variant. It'll make it simpler. V equals g dot get vertices. All right. We don't have to give it anything. That gets a copy of the vertices in an array, and the array will look something like v count comma 2. Remember in VB the array it's the upper bound and not the count, so it'll be 0, 1, 2, or 3 elements in that particular dimension, and the count would actually be count minus 1, I believe. No, it'll be the count. That's right. Okay, so we will go, and it should be accurate. Let's see. Guess the count. Let's see. So let's do d dot ellipse v dot n comma 0 comma vn comma 1 comma, and the radius will be say 2. All right, so that should be, this array is the vertex, the first element in the array would be x, the second element in the array would be y, and we're not going to use z. We're just going to drop the z. Z will be like the in and out, and we're using basically an orthographic or orthometric projection where we just drop the z. Okay, so forget about it for now. And I think that's all we have to do. We need we got begin draw, we got end draw. We might want to set a color. Well, let's see what happens. There's probably a few other things we want to do at some point. End draw. Let's see. A few things I need to do yet. Let's see. Begin draw. We need to d dot. We don't need anti-aliasing, but we do need use fill. D dot use stroke. Oops. Alright, let's see. I was doing for n, so n equals 0. This should be doing something. Another thing we have to do is translate this. Let me also, yeah, okay, it's working. It's just very small. So we talked about using this matrix. Let's go ahead and do something with this matrix. Let's do. We did the basics, so let's do m dot concat, not rotation. Let's do m dot concat scale and make it 100 times bigger. And let's do m dot translate. Not sure if the translation should be before or after, but let's. 100 might be a bit much. Let's try 10 for now. We'll come back to it. Translation should be. Let's add 100 to it. And if it doesn't show up, we'll reverse these. And we need to. Not just translation. We want n dot concat. Concatenate that. Oops. Okay, that's good. And we want to actually apply these, so, So, in fact, let's not do that yet. Let's go ahead and do this as part of the drawing object, then we'll come back and do that as a next step. Let's do this first as part of the drawing. Let's do d dot translate, because it'll be simpler this way. 100, 100. Let's see. Let's just comment these out for now. Or, well, I guess it doesn't matter. And I'm always forgetting that third parameter. Alright, let's see. Do that. It translates it. Not sure where I translated it to. Let's see. There it is. Okay. It's right there. We also want to scale that D. That's the drawing object dot. Scaling 10, 10, 10, whatever. We should start to see this shortly. There it is. It's upside down, but we did get our teapot image. Let's do 50 and see what happens. 50, and we'll scale by negative value so we see it upright. Okay, there it is. I'm going to translate this down a bit more, though. There we go. All right. Clear this. Make it just a bit bigger, say 100. Oops. And 100. Bear in mind, right now we are doing this as part of the drawing and not as actual changes to the geometry. It's just on the fly making these translation and scaling changes as part of the drawing routine. We're going to go in later and do these to the actual physical vertices. So probably in our next video at this point because we're running out of time on this one. But we're making good progress. We're actually parsing an OBJ file